Good morning. Welcome to Natural Science and Health 5. We only have 30 minutes to, I will just help you with the content to prepare for your August examination. Well, this is the outline for the presentation, but due to limited time, we'll just go through quickly, and then we'll look at some examination advice. This is the introduction. We won't be able to cover the whole content of your study guide. And if you have any other question, you can contact me. This is just prepared for you to help you prepare for your August examination that is coming up. You'll be asked to make some definition, especially on distance, speed, and acceleration, as well as calculations. So you can go through nicely for yourself at your own pace. And this is an example of what displacement is. We know displacement is a change in position. When you move, like the first car A, starts from the beginning, it moved for 4 kilometers and stopped, then it added another 2 kilometers and it's finished at 6 kilometers. Then the displacement is 6 kilometers. But if it's just like B, it started from 0, then it goes to 2, then the displacement is 2 kilometers. Then you must subtract if it went back. Then here is an example of how you can calculate the average speed, which we have average speed is given by distance divided by the time taken. And there is an example that is given. I advise that you do the calculations first, look at the question, you do it by yourself, and then you can compare your answer with what is given here. And there is also the number 2. If we look at the number 2, plan and solve. This is a way to guide you on how to answer your question. First, you start with what is an unknown that you are trying to calculate. The question given there is calculating the average speed. And then you will find out what formula would you need to use. Then the formula is given there is speed is divided by distance divided by the time taken, and the calculations are given. But first, try to work it out. What information are you given? What information are unknown? What is the formula that you are required to use? And then here is another discussion on calculations, on acceleration. The formula is given, but below there, the last bullet, any of the following changes can be a form of acceleration. It could be either a faster speed, when something, especially let's look at the car. A car is speeding, whether it's slowing down or there is a change in direction. You must take note when you are doing your calculation, you know, as long as there's a change in speed, whether it's fast, whether it's slow, whether it's a change in direction, that is acceleration if you are asked to calculate the acceleration. And the example is given there for calculating the acceleration the same way. The first one is to read and understand. What is it that you are given? This is a general approach when you are doing calculations. What is that? What is the information that you are given? And the second one is you have to plan and solve the problem that you are given. What is the unknown that you are going to calculate? And then what is the formula? You work out the formula. This is very important for you not to misunderstand the question and do calculations and answer things that are not being asked. Then here you'll be asked to draw graphs, read graphs, explain graph, or discuss them. The first one is a positive acceleration. There is an increase. There is a negative acceleration. That you see the graph is slowing down. The slope is negative, so it's a slow down, and then there is the acceleration over time. The last one, you can see how the acceleration is increasing or with time. And then the next one is the density. We define density as the amount of matter per unit volume. And we know the density is mass over volume. When the mass is increased, the volume stays the same, the density will increase. If the mass stays the same and the volume is increased, the density will decrease. And here you have another example to calculate density, but this is the density of an irregular object. We know the density of regular objects also, you can work through that. The example given here is for irregular object, and the solution is given on the bottom of that slide. So I urge you to work through the example by yourself and see if you can get the same answer. If you don't get the same answer, then something is wrong. Try to find to use the first given method, where you have to first understand what is given, then you look at what is it that you are asked and the information that you have to use and the formulas. Then we come to the forces. Here I'll just highlight the gravity. Gravity is a force, but this force is controlled by the mass of the object as well as the distance between the object. The weight of the object is determined by the gravity, because then the weight is calculated using the gravity. Then here we have weight and mass. Mass is the amount of matter in an object. Weight is a force that we use gravity for us to calculate the weight. We use mass times gravity to calculate the weight. This is a very popular concept. Almost every examination will ask in one way or another, whether it's direct or indirect, you are expected to know how to calculate the weight and the mass. Then here is a calculation for force, mass, and acceleration. An object with more mass will require more force to begin its motion and or to stop the motion. In this cartoon here, this is just to simplify the relation between force, mass, and acceleration. These two fighters, they should have speed, they must be fast, but for them to have more force than the other, they have to multiply their mass by acceleration. The faster they are and the heavier they are, the heavier their forces will be, and that will determine the way the outcome of their fight. Okay, if they are faster, force and mass is increased. If they are heavier, the force is increased, and the force will also increase. Then we are multiplying mass by acceleration. This is just to simplify the relationship between the three. And here we also have another simplification. You see, one is lifting a very heavy stone, the other one is a smaller stone. So obviously, for the one that the bigger the stone, the bigger the mass, will require more force. The smaller the stone, it will require very little force to drag. So this is just to simplify the relationship between the three, so that it can also help you remember when you need to do the calculations in the examination. So force, mass, and acceleration, they are all related. When one increases, the other one increases. When one decreases, the other one decreases. Then we come to the turning effect of the force. That is the moment of the force. The moment of the force, here we are given an example, and work through this example and compare the way I do the calculations here with the way you are doing your calculations, and see if your answers are corresponding. If they are not corresponding, then you can see where you can correct. Hope you get all of it right. Okay, then we have here the clockwise moment equal to anti-clockwise moment. This is the principles of moment. Sometimes you are asked to state it, sometimes you are asked to know it in your calculations. And there is an example there also from that from the previous diagram, and similarly work through the example, then you can see. Okay, then we have forms of energy, different forms of energy. You will be asked to calculate to define what is energy. You can define energy is the ability to cause a change. Energy is the ability to move things. or whichever way you define your energy. This is just a simplified version. And we have two main forms of energy: potential energy, which is stored energy; kinetic energy, which is the energy of motion. And these are further subdivided into other energy. Electrical energy is under energy of motion, light energy, heat energy, sound energy. These are all types of kinetic energy. And then we have potential energy. This chemical energy, elastic potential energy, gravitational potential energy, these are energy due to position, which is stored energy. Okay, then we have the transfer of energy. Here we have the law of conservation of energy, which means energy cannot be created or destroyed, but it can be only changed from one form to another. This is one of the principles that you need to know by heart and be able to define. And then we come to thermal physics. This is a summarized version of thermal physics. This physics deals with heat and its properties and its characteristics. And in this summary, in this diagram, we have three forms of transfers of energy. One is conduction, then other one is convection, and the last one is radiation. Conduction is transferred by direct contact. When you touch a hot pot, you burn. That is direct contact, because you are touching something that is hot. The energy comes from the pot to your hand. You can be burnt. That is conduction. For convection, energy is transferred by the motion of molecules. When particles are moving, then that is convection. It transfers the energy. The example I can give you here is when you warm water. The water that is warming is just at the bottom of the pot, at the bottom of a kettle, at the bottom of a jug, whichever you are using. At that bottom, the warm water moves up. When it moves up, it carries heat with it. Leave it on top, and then when it loses that heat, it becomes cooler. Then it sinks to the bottom, get hot again. That's how that current, convection current, moves around until the whole water boils and all the water molecules get energy. The last one is radiation. Radiation is transferred by electromagnetic radiation, especially the way we get our energy from the sun is through radiation. It doesn't need to move through molecules. It doesn't need any medium. It can be transferred through a vacuum. That is radiation. I can give you an example. Like you see here, the way you can feel the heat from the fire is because of radiation. Then we have the refraction of light. Refraction of light, here you have two examples. We have a dispersion of white light. You need to know these colors of rainbow in their right order, from red to violet. And you can use these abbreviations to help you remember. Like the red, we can say, take just the first letters, Roy, G, Biv. That is like someone's name. We always remember people's name. That will help you to remember. And then we go to lenses. There are two basic types of lenses. Here I only put one. Or I put two, converging and diverging. And you must also know how these are used to correct the sights, especially sight defects. Then we come to electricity. Electricity is a force created by difference in charges. And we have electric current, which is a movement of electrons. You need to know some of the electrical devices like electric motors, and you need to know electromagnetics. Let's discuss quickly the electromagnetics. Electromagnetics have two advantages over normal magnets. They can be turned on and off. Their strength can be changed based on the amount of the current that is flowing. That is the goodness of using electromagnetics. Electromagnets, that's why they are used in most of electric devices like electric motors. Then we have electric circuits, which are arranged either in series or in parallel. This is one example of how to draw the electric circuit. We have a battery that is connected to two bulbs, and these are connected in parallel. Each bulb has its own path of electricity, therefore the amount of electricity is the same for every bulb. Then we have another one here. What are the advantages of having a circuit with bulbs in parallel? When one bulb lights up and the other one fuses, the one that lights up, it will still continue to be lighting up. But if it's in series, one blast, then the other one will also not light, even if it's okay. This is the arrangement of the bulbs that are connected in series. And when one fuses, the other one will also no longer light up. Then the last topic we cover is the nuclear physics. Nuclear physics, we are talking about mostly concentrating on radioactive decay. What is radioactive decay? Radioactive decay is when a nucleus breaks up because it's unstable, and when it breaks up, it gives off some particles. These are the particles that we need to know: alpha particle, beta particle, and the gamma rays. We don't say gamma particles, they are rays, they are not particles. And their symbols are given there, and the masses are given, the charge is given, and then we go a bit deeper: the ionizing ability, penetrating power, and which one can stop them. So you need to know these properties very well. It's just a summary of what's in your guide, but if you go to your guide and compare with this table, you'll be able to understand very well. And the last one that we normally calculate is the half-life. Half-life is defined as the amount of time required for a quantity to halve its value as measured at the beginning of the time period. When you have an amount, let's say two particles, and the time it takes, because we are talking of a decay, the time it takes for it to be half of it remain, the other half disintegrates or breaks down, then that time for it to divide into half is what we call the half-life. Let's look at this example. This example, we have a concentration of 1.6. 1.6, if you divide it by 2, it gives you 0.8. That is the first half-life. And then you go to the second half-life, you have 0.8, and you divide it by 2. 8 divided by 2 is 4. So that is the second half-life. And then 4 divided by 2, you have 2. That is the third half-life. That is how you work out graphs that are for half-life, for calculating the half-life decay. Here you are given an example, and it's worked out nicely for you to show you how you work out the half-life, and then the answer is given there. The question is that one in blue. So if you try to work it out on your own and compare with the method that is given there and see if you can get that answer, which is 90 days. And we come to examination advice. You need to read the examination. This is where I want to spend most of the time, because you are preparing for your examination. The content that I have just discussed is part of your study guide. I believe you have already been studying using your study guide when you have gone through your assignments and when you are preparing for the examination. But I want us to look at how you prepare for your examination. This is very important, because most of the time you might know the content, but you don't know how to answer. You might know, or you missed reading the question, especially if you don't read very carefully, then you miss the point. Read the questions carefully and fully. Look for details that indicate how to answer the depth of how to answer, or the depth of answer that is required. For example, look at this question. Describe in terms of the movement and energies of water molecules how evaporation takes place. And you are given 2 marks on the paper. You are asked to describe in terms of movement, because it's telling you in terms of, it's even prescribing, and you are given 2 marks. This shows that you must take 2 valid points, and you must refer to the movement, because it says describe in terms of movement. You must refer to the movement and energy of the molecule. So when you talk about the movement, you get 1 mark, and then some wording such as have more energy and so on, then it gives you another mark. Then that means you get 2 full marks, because those 2 marks are only allocated for in terms of movement and energies. If you describe, you can describe movement in evaporation in many other ways, but here you are asked, and it's very specific, so you must read very carefully and see what is required, otherwise you miss the marks. Make sure this is physics based, and you need to use your calculator. You must be very nicely conversant with your calculator and with your mathematics also. Show your working in calculation so that you gain marks for your method, even if you make a mistake with the final answer. So when you show your calculation, even if the final answer is wrong, you'll be able to get some marks. Always include units where appropriate. Please do include units. You get a mark for the correct units. Avoid vague descriptions. Try to write clearly and concisely using the correct physics terms. At the end of a calculation, ask yourself, is this answer sensible? Does it make sense to you? If it doesn't make sense to you, then maybe there is something that you need to relook at. Make sure you answer the question set. You will gain no mark for merely repeating the facts given in the question. Then some guide on how to read the question. Reading the questions before you answer the questions. It is very easy when presented with a diagram question to look at the diagram and try to answer the question. You must read and understand the introductory sentences above the diagram first before trying to answer the questions. Maybe you just see the diagram and it's something that you have seen in your study guide or in the assignment, and you think, okay, I know this, it was there, but you didn't read. There is something that might have changed, or the questions might have changed, so try to read. There may be a part of the question near the end which require you to use a piece of information that is included in the introductory sentences in your answer. Sometimes at the end, like the questions A, B, C, the question C might include some facts that are mentioned at the introductory sentence, and you might need to use that information. Be careful how you answer your questions. An explanation of some physics, even if it's correct, does not answer the question set, does not score marks. So if you just say any physics terms, even if it's correct, as long as it's not the answer to that question. For example, I'm asking you about distance. How long is that distance, the length? And you answer with the time in seconds. You are telling me for the distance, you give me the answer in time. That will not score you any mark because you are not answering the question. If there are 3 marks available for a calculation, 2 or 3 marks are for showing your working. So if you know the answer and you just punch in the numbers in your calculator and you give the correct answer and you say it's 2 ohms and there's 3 marks, you don't get the full 3 marks because you did not show your calculation. The other marks will be, the 2 marks will be for showing your calculations. If a question states accurately mark or correctly draw, we expect points, example a center of gravity, to be carefully positioned and lines to be drawn with care using a ruler, not just free drawing. In the case of ray diagram, it is expected that the rays drawn should pass at least within 1 millimeter of the relevant point, example the principal focus. When reading the questions, decide which area of physics you are being asked about. Do not just look at a few words, as you may then misunderstand the question. For example, a question that mentions heat radiation is not about radioactivity. If you are asked for a convection current diagram, do not draw a circuit just because the word current is in the question. So you must be very careful how you answer the questions. This I'm pointing out and I'm stressing depending on how you answer your assignments also. Try to be careful with this. And then answering the questions. Here are some examples that shows the type of understanding that is required to answer the questions successfully. You must understand the turning effect of a force, and that is called the moment of the force. Turning effect is the moment of the force. You must understand that very well. You must be clear about the names given to types of energy and use them appropriately. You should know the circuit symbols required for use in describing electrical circuits. The symbol for a fuse is often not known, and the symbol for a thermistor and a variable resistor are commonly confused with each other, especially in cases where you are asked to draw. You are just given a diagram. You are told in a circuit there is this and that and that and that. There is a thermistor, a variable resistor, a watt, and you are asked to draw that. Sometimes the symbols are confused with each other. You must know how to connect a voltmeter in parallel with components across which are measuring the potential difference. You must have a clear understanding of electromagnetic induction. For example, you must know when a magnet is moved in or out of the solenoid that is part of a circuit, or a current is being induced. You must understand the difference between mass and weight. This I have already stressed at the beginning. You must also understand basic radioactivity. You should know about the characteristics. Okay, I wish you all the best with your examination. And here are just some of the things that you need to focus on for your August examination that you are currently preparing for. Look at the motion, the things we discussed also, and look at some more acceleration, speed, and distance, and the calculations involved. You look at the density, the mass and gravity. I have already stressed that enough. Forces, that is moment, the turning effect. Thermal physics. There is more to thermal physics than what we just discussed. But if you go to your study guide, you need to study and focus on thermal physics. Not only the transfer of heat, other properties of thermal physics also. You look at the sound, especially the echo of the sound, refraction, the triangular prism, the refraction we discussed, and the lenses. You look at electricity, conductors and insulators. We did not discuss them. Energy, their forms, their sources, the disadvantages and advantages. You look at the electricity, especially the motors, the AC motors and DC motors. You calculation of electric circuits involved in the electric circuits, which are calculating when electric circuits are in series and when are in parallel. And then the half-life. Focus on mastering some of this for your examination, and you'll be nice and ready. If there is any other question, feel free to contact me. I will be glad to assist. If there is something that you do not understand,